Hello everyone. Today we are going to discuss about Hitler London treatment. Okay. So, so what do you know about the hydrogen molecule? So, in hydrogen molecule we have the two nucleus, okay, and two electrons. Means in a hydrogen molecule you have two atoms, two pair of atoms. So, each atom consists of one nucleus, one electron. Okay. So let one electron be as name it as A and another electron name it as B. Okay. So the first the one electron is name it as 1 and another electron is name it as 2. Okay. So first we assume that the electron is in the nucleus here. This the second electron is in the nucleus B. Okay. So the distance between the A and first electron, the first nucleus A to the distance between nucleus A and electron 1 is R1A. The distance between the nucleus and nucleus is R, and distance between nucleus B and the second electron is R2B. So distance between the two electrons is R12. Okay. The distance between second distance between nucleus A and second electron is R2A. Distance between second nucleus B to first electron as RB1. Okay. So this the whole thing is the hydrogen molecule. So in hydrogen molecule has four particles. So four particles are two electrons, two nucleus. Okay. So two nucleus is described by the Hamiltonian. The first of all the here nucleus A and B are repulsive in nature. Means both nucleus are repel each other. This this first electron this first electron and second electron is also in the repulsive nature. Means they both electrons are repel each other. But this nucleus and the electrons are attractive to each other. Okay. Attracted to each other. So is described by the this four particle system is described by the Hamiltonian. See, here we have written the total Hamiltonian as the kinetic energy and the potential energy. So Hamiltonian is nothing but the energy operator. Okay. So we have written the total energy as kinetic energy, sum of kinetic energy and potential energy. One second. See. So of minus of delta minus of del 1 square is the kinetic energy of the first electron. Okay. See of minus of del square del 2 square is the kinetic energy of the second electron. Okay. See the minus of ma del a square is the kinetic energy of the kinetic energy of the nucleus. Okay, see, minus half ma del del b del b square is the kinetic energy of the nucleus. It means nucleus b. Okay, so we have written all the kinetic energies of the four particles. So now turn is of we have to write the potential energies between these particles. Okay, so you have a nucleus A here. Okay, the first electron. So what is the distance? There will be potential energy developed between these two, between first electron and the nucleus A. So what will be the potential energy? Minus 1 minus 1 R1 A is the attractive potential. Okay, there will be attraction between this first electron and the nucleus A. That's why have the minus sign is came. Okay, next one is the potential between the nucleus A and the nucleus and the second electron. Okay, next the R2A means attraction potential energy between nucleus A and the second electron. Next one is nucleus B to the first electron. Okay, then there will be a there will be repulsion between there is a two repulsion terms. One is between between the electrons and between the nucleus. Okay, that's why we have written the for nuclear for for repulsive for repulsive for repulsive terms. So the potential will be positive. So positive of 1 by r12 plus and r. Okay, so we have written the Hamiltonian for the hydrogen atom. Okay, so in the terms of coordinate as shown in the figure, we know first that the masses of the nucleus are much greater than those of the electrons. So if the mass of the electron is one atomic unit, compared the take it let us assume like that the mass of the electron is one atomic unit, then it is much heavier than it is much less than the mass of the proton. The mass of the proton is 181 1836 atomic units. Okay, that means the mass of the electron is much smaller than the mass of the proton. Okay, so um, therefore the kinetic energies will be negligible, uh, small compared to those of the electrons. So compared to the electrons, the mass of the nucleus are heavy. Okay, so the kinetic energy of the mass of the nucleus are become the will be heavy, means will be more. Okay, compared to the mass of the electron. So mass of the electrons are the kinetic energy of the electrons are very less compared to the uh, will be more will be less compared to the mass of the means sorry, the kinetic energy of the electrons is some is will be less, uh, will be high. The kinetic energy of the electrons will be high compared to the kinetic energies of the nucleus. I repeat again, the kinetic energy of the electrons is much greater than the kinetic energy of the nucleus. Okay, because the mass of the nucleus is less than the mass of the proton. Okay, so in accordance with the von Hepler Oppenheimer approximation, we can first consider the electronic Schrodinger equation. Okay, so consider the only the first consider only electronic Schrodinger equation. Means electronic Schrodinger equation means minus so electronic Schrodinger equation is minus of del 1 square minus of del 2 square. Okay, and um, plus all the potentials. Okay, plus all the potentials. This is the electronic this is Hamiltonian for the electronic systems. So internuclear separation mean R occurs as a parameter in this equation. So here R is the distance between the two nucleus A and B. So which can the distance can vary. Okay. So that Schrodinger equation must in concept be solved for each value of internuclear distance R. A typical result for the energy of a dynamic molecule as a function of R, as shown in the figure. This is the figure. This is the energy curves for the dynamic molecule. Okay. Um, for bound system, for bound state means here the region is bound state up to here. Below the zero, uh, below negative values of energy, the states are bounded. Okay. So for bound state, the energy minimum occurs at the R is equal to RE, is known as equilibrium internuclear distance. So at R is equal to RE means RE is the position of the equilibrium of the nucleus. Okay. So the depth of the potential well at RE is called binding energy or the dissociation energy. For H2 molecule, the dissociation energy is equal to 4.746 electron volts and Re is equal to 1.4 Bohr, Bohr is equal to 0.7406 angstroms. So note that see how we got this curve. Okay, let me explain. Let's use the tools. Okay. So Hamiltonian of electron is you have 1 by r term, right? 1 by r, okay, which is equal to, when put r is equal to 0, then it is goes to the term 1 by r goes to infinite. Okay, so see, I will write here explanation. Okay, okay. So 1 second, wait a second. Wait a second. So wait a second. So write 1 by, so now take the r is equal to 0, so infinite, then r becomes, so 1 by r becomes, goes to 0, right? So like that. So when r is equal to, when r is equal to 0, so 1 by r goes to infinity, so energy will be goes to infinity. Okay, when r is equal to infinity, when r is equal to infinity, then energy will become 1 by r term become 0. Okay, it goes to 0. So the curve will come like this. If you take the negative values, the if we join all the points, you will get this curve like this. So what I'm trying to say is okay, see, take 1 by r. Okay, so more massive nucleus move much more smaller. ఇప్పుడు ఏవైనా మాలిక్యూల్స్ పెద్దగా ఉన్నాయనుకోండి, అది ఎక్కువ డిస్టెన్స్ ట్రావెల్ చేయవు. సో ఎలక్ట్రాన్స్ అనేవి లైట్ పార్టికల్స్, సో వెరీ డెలికేట్, సో మాస్ అనేది చాలా తక్కువ, సో ఇట్ కెన్ మూవ్ మోర్ డిస్టెన్స్ దెన్ ఎలక్ట్రాన్స్. ఫ్రమ్ ద ఫ్రమ్ ద వ్యూ పాయింట్ ఆఫ్ ద న్యూక్లియస్, ఎలక్ట్రాన్ adjust emo, emo, almost instantaneous to any change in the intermolecular distances. సో ఇప్పుడు మాస్ ఆఫ్ ద న్యూక్లియస్ అనేది హెవీగా ఉన్నది, సో న్యూక్లియస్ అనేది మాస్ ఆఫ్ ద న్యూక్లియస్ అనేది చాలా తక్కువగా ఉంది. సో ఇప్పుడు ఫ్రమ్ ద వ్యూ పాయింట్ ఆఫ్ ది న్యూక్లియస్, ఎలక్ట్రాన్స్ ఆర్ వెరీ వెరీ లైట్, మీన్స్ అడ్జస్ట్ ఆల్మోస్ట్ ఇన్స్టంటేనియస్లీ టు ఎనీ చేంజ్. ఇప్పుడు ఫర్ సపోజ్ ఎలక్ట్రాన్స్ అనేవి ఎలా అంటే ఒక పీస్ ఆఫ్ పేపర్ లాంటివి, అని ఊదితే ఎగిరిపోతాయి, మీన్స్ డిస్టర్బ్ అవుతుంది, ఆ స్టేట్ అనేది చేంజ్ అవుతుంది కంపేర్ టు ద మాస్ ఆఫ్ ద న్యూక్లియస్. ఇప్పుడు మాస్ ఆఫ్ ద న్యూక్లియస్ అనేది అని నవ్వుతే ఎగరవు, అలాంటిది అలాగే. ఓకే, సో electronic energy therefore plays a role of potential energy in the Schrodinger equation. So ఇప్పుడు now we consider only the kinetic energies of the nucleus. Okay, which is given like this. So chi of Ra and Rb is chi of E into chi of Ra comma Rb. From the solutions of the equation 2, from the solutions of the equation 2, the solutions of the equation 2. Okay, the solution of the equation 4 is the solution. So chi of r comma ra comma rb is the solution for this Schrodinger equation. Okay, that determines that chi of ra comma rb determines the vibration and the rotational energies of the molecules. These will be considered further in the chapter 13. We will see that we don't have that chapter. For the present, we are interested in obtaining electronic energies from the equation 213. From the equation 213, so we want to obtain the solution for this. We are interested in obtaining electronic energies from the equation 213. We will thus drop the substrate electron on the Hamiltonian and EF for the remainder in this chapter. Okay, అదే గుర్తుపెట్టుకోండి. సో నేను ఆల్రెడీ ఒకటి చెప్పాను. ఇప్పుడు న్యూక్లియస్ ఇప్పుడు మనం ఏమైనా ఎస్యూమ్ చేసుకున్నాం, ఫస్ట్ ఎలక్ట్రాన్ అన్నది ఈజ్ ఎగ్జిస్టింగ్ ఇన్ ద న్యూక్లియస్ A, the second electron is existing in the nucleus B. Okay, so the wave function associated with the first electron is psi1 s r1a. Okay, psi actually that is 2 psi2 s r2b. Okay, the wave function. Understood? So we can write the combined wave function as the psi of r1 comma r2 is equal to psi 1s r1a into psi 1s r2b. Okay, the first quantum mechanical count of the chemical bonding is due to chemical bonding is due to Hitler and London in 1927, the only 1 year after the Schrodinger equation was proposed. The reason that since hydrogen molecule was formed from a combination of hydrogen atoms A and B, as a first approximation to its electronic wave functions might be. Okay, సో ఒక ఏమనుకున్నానంటే హిట్లర్ అండ్ డాప్లర్ ఇప్పుడు హైడ్రోజన్ మాలిక్యూల్ ఎలా ఫామ్ అయింది అంటే ఈజ్ ఎ కాంబినేషన్ ఆఫ్ 2 atoms which consist of a two nucleus, two electrons. Okay, so and the first approximation is electronic wave function might be like this. It means first electron may exist in the first nucleus. The second electron is exist in the second nucleus means nucleus B. First electron is exist in the nucleus A, second electron is exist in the nucleus B. So then we can write the combined wave function for this 2 electrons. Okay, so for every electron there will be one wavelength is associated with it. Okay, so we haven't discussed the variation principle till now. The variation principle will come in the second unit. So the total energy of the system can be written as integration of psi into h cap psi tau means the volume of the volume element divided by integration psi square d tau. Okay, so both radius of a electron is the distance between the nucleus is obtained as 1.7, indicating that hydrogen atom can be indeed form a molecule. So binding energy is much too small to the account for the strong bond H2 molecule. Either Hitler and London proposed that it was necessary to take into account. So what the Hitler and London proposed that we have to account the exchange of electrons also. So we have to take the account in the exchange of electrons also. So first we have taken first electron is in the first state and second electron is in second state. Now exchanges electrons and then write the wave equations. Okay. That wave equation will be the symmetric form, symmetrizer function. Okay. This is the wave equation. Equation 8 gave much more realistic binding energy value is 3.20 electron volts with Re is equal to 1.5 volt. Okay, this is the enough for today. So we have discussed the Hitler and London treatment. Okay, what summary of this Hitler and London is theory. So hydrogen molecule have the two is made up of the two atoms. Molecule is made up of two atoms. Each atom consists of one nucleus, one electron. So finally there is a four particles in the hydrogen molecule. Okay. He said that the first now exchange the molecules, exchange the electrons. It's not molecules. Exchange of electrons. Not first point is so the first he assumed that the electrons first electron is in the nucleus here. Second electron is exist in the nucleus B. Then he wrote the wave function for the combined system. So it means each electron for each electron the wavelength is associated with it. Okay. Uh, then he assumed that then he assumed like this. Then he exchanged the electrons. Okay. So second electron is exist in the second in the nucleus A. First electron is exist in the nucleus B. Then he wrote the wave function. That wave function will be a symmetric function. So proposer it was necessary to take into account the exchange of electrons, in which the electrons labeled in the sixth has reversed. Then proper symmetric function is like this. Okay, thank you.